Hi guys, I'm Shreshta and we're going to be learning science. But today is quite interesting because we're going to be learning about something called the pinhole camera, and we're going to be learning how it works, which is very interesting, okay? So before that, I just want you to envision this, okay? So envision that you're in this room. Yeah, you're in a room that's very dark, and there are two holes in the roof, and the light is coming in through those holes. Yeah, and you see this circular thing at the bottom. It's the light shining, but it's shining in a circular way. So have you ever questioned that? Why is it circular? Well, the answer is it's because this circular thing is the image of the sun. It's the actual image of the sun, which is very interesting. And the good thing is that we will be learning how this happens, okay? And this is exactly how a pinhole camera works. Of course, this image is much smaller. So in this case, this circular image, even though it is the image of the sun, it's much smaller than the sun, obviously. And yeah. So first, let's understand what a pinhole camera is, okay? So this is what a pinhole camera looks like. It's the simplest camera ever, and it's basically a simple optical device that makes an image without a lens or a mirror, okay? And the most important thing here is that it consists of a light-proof box. This box needs to be light-proof. And what do I mean by light-proof? What I mean by light-proof is that there should be no light in the box. There should be zero light in the box, okay? And it should have a sort of a film, and this film can be, let's say, a tracing paper, yeah? And obviously it needs to have a pinhole. It needs to have a really tiny hole, okay? And one more important fact is that pinhole cameras mainly rely on the fact that light travels in straight lines. Okay, we all know that light travels in straight lines, and pinhole cameras rely on that. They rely on this factor, okay? So, okay, I drew this. I know it's a horrible diagram, but it'll help you envision how pinhole cameras work, okay? So imagine you're in a dark room-sized box. So this is you, this person is you, and this place is completely dark, yeah? And you have a friend on the other side, okay? And she or he is standing, and there's a really tiny hole in the door, on the door, okay? So this is the door, there's a small hole, this is your friend, this is you in a very dark room, okay? And your friend holds a torch and shines light through the hole, okay? Now what you see is that you'll see two straight lines, as you saw earlier, and a small dot, yeah? And as your friend moves the torch and changes the angle at which the torch is shining through the hole, this dot will move, yeah? So if the torch moves that way, the dot will move this way, yeah? And this is how a pinhole camera works, okay? What happens is, if your pinhole is very small, when the flashlight flashes through the pinhole, the light going into the dark room will be very sharp, yeah? And in comparison, if the pinhole is big, the light from the torch, the light that's going through the pinhole, won't be that sharp in the dark room, okay? So this is a very good proper diagram of a pinhole, and you need to understand this, okay? So if you're using this pinhole camera, your eye will be here, okay? And you will look at whatever you're looking at through this hole. Okay, and suppose you're looking at a tree. Yeah, what happens is, let's just say M is the top of the tree and N is the bottom of the tree. Now, interestingly, the light rays from N, which is the bottom of the tree, goes through the pinhole, and then it goes up. Okay, so N now on this tracing paper, this is the tracing paper, this is the film, N will be on the top, and M, if you see this diagram here, M, which is the top of the tree, the light rays from M will go through the pinhole and shine at the bottom of the tracing paper. So the product you get is actually a flipped version. It's upside down, as you can see here. Okay, so this is the proper tree and this is the image that it creates. The image that it creates is inverted. Okay, that's a keyword. Inverted means it's upside down. Okay, and one more very important thing is that the image is much smaller. Okay, so this diagram it doesn't represent real life at all. In real life, this pinhole camera would be much smaller and this tree would be much, much bigger. Okay, this is just a diagrammatical representation so that you guys understand. Okay, and as I said before, the smaller the pinhole, the sharper the image. Yeah, so if this pinhole was even smaller, the image of the tree would be more clear. Okay, so over here what happens is, the pinhole actually is acting as the lens. Yeah, so the pinhole forces all the light from the tree to form a small point on the film, and this point on the film is actually the image. Yeah, so yeah, that's basically how it works. The main key points is that the image that is formed on the film is much, much, much smaller. Yeah, and it's inverted, and the smaller the pinhole, the more clear image. Okay, thank you guys. I hope you liked today's lesson. Comment down below if you have any questions at all. And I know this topic is a bit hard to understand at first, and don't worry, just go through this video a couple of times and I'm sure you'll get it. Bye.